My name is Anton Keks. I come from a company called Codeborne. So who knows about that company? Okay, so we don't need a lot of introduction. That's a good thing. In a couple of words, we are craftsmen. We call ourselves craftsmen. We do agile software development. We do all kinds of different projects, and by being craftsmen, it means that all our employees, or most of our employees, are actually engineers. And it means that we don't have specialists for testing or for security, for example. And it means that we all need to know about security when we are developing our projects. So now, today I'm going to share my story of building an internet banking project from scratch. You don't get an opportunity to build a new internet bank from scratch very often, but we had it. We have a background in Swedbank as well, in case you don't know. But now we have two internet bank customers in Russia. I'm going to show you very quickly what these things are. We have two banks currently up and running in Russia, and we did some innovative stuff for the internet banking. So if I log in, I'll tell you more about the authentication stuff that they actually offer. But we have lots of innovations here that I really hope that the Estonian banks will catch up and will do something like that soon. For example, instead of filling very ridiculously difficult forms for making a payment, you can just search for any of your previous payments or some of the known vendors, whatever, and you can actually complete the payments very quickly without delving very deeply into the complicated laws of Russia that governs internet banking. And the second bank, the one that I showed you, is the Bank St. Petersburg. It's not so far from here. And the other one is the Ural Bank. The interface is only in Russian for those guys. They are pretty far in near the Ural Mountains, so they don't care about any other languages besides Russian. So in St. Petersburg, they needed to have English as well, but there in the Urals, they don't need. So basically, we have some innovative internet banks built from scratch, and now I'm going to share the story of building them from a security perspective. So yeah, I'm happy to answer any questions as soon as they arise, basically. So today's conference is actually, as far as I hear, it's mostly about the operation stuff. So, and because basically ByteLife, I guess, is the operations company focused on that. So we are focusing on the development. So I will going to skip all kind of data center and networking and DMZ and all kind of operation stuff in terms of security, and we'll focus on the development. So this is the previous speaker actually mentioned some development practices. So this is what I'm going to talk about. So in general, to theorize, if you're a developer and developing a new web application, be it internet banking or anything else, it means that you need to think that browsers should not be trusted, never. So this is the mistake that many developers actually do. So they think that if it is their own code in the browser that is sending data, then they can trust it. So any input can be actually mangled. It basically means that on your server side, all your entry points should be defended pretty thoroughly. So any input parameter can actually contain any malicious code, malicious data that will try to blow up your system. And it means that for the developers, the general message is that they need to think like a cracker. So if you write new code, you always need to think, how would a hacker try to actually break it? What kind of inputs the malicious guy would actually try to send to your application so that it will break or it will actually return the non-authorized information. So this is all theory, and the stuff. Another thing is that whitelisting. So a lot of times when people, especially developers, they think about security, they think about blacklisting some stuff that is should not be accessed or something like that. So the only actually viable option of preventing the access is to actually whitelist the stuff that can be accessed and deny everything else. So these are the theoretical stuff. That is the general rules that any developer should follow. And by the way, how many developers do we have in this room? So about like 1/5 or something, even less. So if you are not a developer and listening to me, then this is the message probably you should bring to your developers if you have problems with them. Maybe you don't. So the problem here is that lots of web applications nowadays are written actually by inexperienced novice programmers, for example in PHP, and they often forget about the basics to actually defend their systems. So let's go now to some trade-offs, or actually the so when you think about security, and we do our projects in Agile way, doing an Agile way means that you have very step-by-step process without very long-term planning. And all the people who I listened to today, they actually were pro or thinking about actually that security needs an extra steps in the process and everything like that. So that may be true, but the biggest thing that actually that you need to know or do in an Agile project is to find that security, both security and Agile, they have one common thing, and this is the testing that you need to follow. So what I'm talking about is the regression testing, is that making sure that your bugs doesn't come or return, and the second thing is the penetration testing. So with our internet banking projects, actually, the customer of ours, they actually hired a third-party company in Russia who did the penetration testing of our internet banking solution. And I was very happy to know the results, because the guys actually were so surprised that that was the first web application that they couldn't actually break into. That they have tested. It was a Russian company called Group IB that did the test. I guess that they are the professionals of this field. And my message is that anything that you do, you still need to have the professionals actually review the system and actually try to break into. So that goes about testing. When we talk about testing from a development point of view, you need to test your security code for all kinds of situations. So basically, what we do, that we write in both unit and UI testing, we actually try to, in the tests, send also the wrong inputs, especially if it concerns login and this kind of stuff, so that we have an automated suite that ensures that after changing our system, we don't introduce bugs that will allow bypassing some of the security methods. And in case you have found the vulnerability, and we sometimes do find something in the process of development by reviewing code, then you need to have tests that actually cover that this vulnerability will not return. So, and the second trade-off is actually security versus usability. So very often security guys, they actually kill the usability, and there are also another guys who kill the usability. These are the lawyers. Lawyers also like to make things more complex than they actually are. So there's always a trade-off, and we have, for example, two customers on production with our internet bank, and one of them actually is willing more to actually sacrifice security, but by providing more of the usability. Of course, there should be a very good limits or good reasons of doing so, and we do consult them on what is a good idea and what is not. And the other customer is more towards the security in some aspects, and they are willing sometimes to sacrifice usability. But in any case, sometimes you can actually have both, but you need to think about that, about the ways how to do that. So now let's go to the practical means, actually. Our application, our internet banking platform is built on a Play framework. So Play framework is a very good start for the secure web application. I'm quite happy with what Play framework can do in terms of security from the out of the box. It actually prevents many of the common vulnerabilities that people usually do in many of the other frameworks. So it's essential, actually, because developers are humans, and humans, they actually do mistakes, make mistakes, and if developers, it's very easy for developers to forget something, and it's very essential that the framework or a platform you're building on top of the framework is actually tries to prevent these mistakes of being abused as much as possible. So that also goes for, you can also have, just in case, like application firewalls and these kind of things, which are defending your application, but of course you cannot rely on them. So Play framework, I'm pretty happy with that. Let's see how it goes with the common vulnerabilities that exist in web applications. So the first one, actually I'm not sure about the background of the audience here, so everyone knows what that is? Cross-site scripting. So very basic type of vulnerability. Nowadays, I think it should be very, people should not feel good if they have this kind of vulnerabilities in their programs. It should be avoided by the framework, basically. And Play framework, it actually, it avoids this stuff completely. So basically, there is very hard for you in your code to introduce cross-site scripting. All the data that you actually passes from your code to the HTML, it's escaped by default. So yeah, and it's very important to have this kind of protections by default, and only when you need some of the data not to be escaped, then you need to do something specifically which is less convenient to actually bypass this automatic protection. So Play does pretty good at that. So, and it's crucial to do that in your framework. So nowadays, actually, and many frameworks nowadays do that, protect you from this stuff. But nowadays, I see more problems with JavaScript. So nowadays, people write a lot of JavaScript in their own code, and usually, if I find cross-site scripting bugs, they are from the JavaScript, from some dynamic web page code. So usually, if you use jQuery, then actually my big advice is to look for this method calls, function calls in your code and eliminate all of them. So as far as I've seen, that was the most common source of XSS vulnerabilities, that you basically take some data and you blindly insert it somewhere in your document. So for the data, or for inserting some data into the document, it's much better in most cases to use text, which will actually automatically, again, escape the data. It will not allow any code to be executed on the page itself. And the same goes about the client-side templating engines, which also take some content and output them. So it's very common for these client-side frameworks to not escape your content. So you need to check your framework before using that. So the next one, actually not only SQL injection, but all kinds of injections. So this problem is mostly solved for, again, most of the frameworks. So I hope that most of the developers now know that putting an SQL strings, concatenating SQL strings in your code and then executing them in a database is the worst thing you can possibly do. But it also goes not about the database. For all the database APIs, the good newer database APIs that I know, they actually provide the option of binding your input parameters. So if you're searching for a user in your database by username, for example, then you should not put this username, the string that was entered by the user from a browser, directly into your SQL expression, because user can, or the malicious user can put any kind of code that will get executed there in the database. Instead, you just put the question mark there and bind the data separately from the SQL statement itself. So the same problem nowadays, it's more common to have these in other areas, not in SQL. So one good example is XPath. So if you are processing something, doing any other types of queries besides SQL, you should also think that if you are composing some query expression in your code which contains user input, then you need to escape that. So you need to think that the user, whatever you do, the user will find, if you don't escape it, the user will find a way of actually putting some more code into the expression, and they will get more information that they're supposed to be getting. So with Play Framework, it uses Hibernate underneath and the JDBC. So with Java and Hibernate, so with database, you don't have this problem. But if you are writing your custom code, you need to always think about these things. So who knows that one? So what it is? Yeah, so this is the request forgery. Is basically means that somebody can send an email link, and if you happen to be logged into your internet bank, this link can actually, user, if it clicks about that, this link will get your cookie of the active internet bank session and probably do something in the internet bank. Yes.
You can even use it as an image node, and then you just visit a malicious website.
Yeah. That can be any link in a malicious site or the email. And actually, that's the thing that which is less familiar usually to the developers. So developers usually know well about the cross-site scripting and SQL injection. For some reason, they are like more common, more famous. And this guy is the number 3 that should be avoided by the developers. Because no matter how good your operations guys are, how good servers and the stuff, if you make a single small hole in your code, then actually your application will be vulnerable. So the common way of dealing with this kind of vulnerabilities is to use authenticity tokens in all of your requests that change data. In terms of internet banking, it means that all the things where you can change something, for example, save some data, save settings, or send a payment, or whatever, you always need to include a random authenticity token together with the data that is submitted by the user. And this token should be separate from the session that you have in a cookie. So basically, so that it would be impossible to craft a link that would do something on your behalf without knowing this authenticity token, which is different all the time. So for Play Framework, it has a built-in functionality of authenticity token. It is very good for a framework to provide this functionality to you. So basically, in Play Framework, when you create a form that is submitted, so it's always by default includes this authenticity token, and what you need to do on the server side is to actually check that. So it's easy to forget to check that, so it's better to invent a way of actually detecting and checking this automatically so that you don't forget to do that for every important request. So, and another thing that actually saves us from this type of attacks is the two-factor confirmation. So basically, in the internet bank, we use two-factor confirmation for most of the write operations. Like if you send a payment or even if you change your setting, you always need to confirm that change with a second device, like your mobile phone. The most common way is to actually the bank sends SMS to your mobile phone, and you enter the code that you have received. It's not the perfect way, but at least it involves a second device that actually protects you completely from this kind of attack for these kind of actions that require this SMS sending. And we support also, in our internet bank, we support also other mechanisms. Of course, in Russia, the Estonian ID card or mobile ID is not available, unfortunately, but they have other options that I'm going to talk about soon. So, and the next one, who knows that one? Nobody? Oh God. Okay. Last one, actually, a couple of days ago, while preparing for today's presentation, I read a report from one international penetration testing company who actually, I think they have checked like 20 internet banks, and they have gathered a report with statistics of what kind of vulnerabilities they usually find. That was number one. And what that is, it stands for XML external entity. So I'll quickly show to you. So that's pretty important because I even read reports of guys actually hacking Google with this kind of vulnerability. So one of the Google services was also vulnerable, and they got like a $10,000 prize for sharing this vulnerability. So how it goes is basically if you accept an XML data as an input into your application from the user, then in most cases, if you don't know what that is, then you are vulnerable. So the thing is that when the XML is accepted, or most XML parsers, especially those in Java or .NET, they support embedded doc-type declarations. And with doc-type declarations, you can actually define new kind of XML entities. For example, if your XML is very easy, like foo, there can be an entity like with any name. So it looks like the regular XML entity. It starts with ampersand, ends with semicolon, and but in the doc-type, you can actually define that the content of this entity comes from, for example, etc path, or basically any file on the system. So it can be any file on this file system, or it can be any URL. And if your parser is with the default settings, it will actually go fetch this file and return it to you. So if you have a way of seeing the result of this entity being expanded somewhere, for example, in the next form after your XML is submitted, then you can actually basically see any file on the server. And it's a very huge vulnerability, basically. You can do with that, you can combine it with other vulnerabilities, and you can get very often very far with your attack. So read about that if you don't know, and if you have any application that actually works with XML, then read about that and configure your parser to avoid this vulnerability. That's number one currently in web applications. So do not accept XML as input or configure your parser. So, and another thing that actually uses a similar approach is XML bomb. I'm not going to talk about that. You can also Google that. It's basically a way of sending you like a 1 kilobyte or even less of XML that will expand to 3 gigabytes when it gets parsed, and it will actually crash your server. Also, you can configure your parser to prevent XML bombs. And buffer overruns. So nowadays, or currently today, I already heard one mention of the Heartbleed and all kind of, that's why I decided to mention that. So the point of how to avoid buffer overruns is to use a higher level programming language. We use Java, and it's at least we are safe from buffer overruns. And I think most of the software nowadays should be written in a higher level language that actually will make this kind of attacks impossible. So I think in the history of computer industry, that was the biggest actually flaw that has the most of the attacks on software. So now let's talk about not about the common vulnerabilities, but of the different kinds of things that a web application does and how we actually solved or improved that. So the authentication. So most web applications, or the web applications that we specialize on, which are not plain static websites, they require some kind of authentication and authorization. So Play Framework has the secure module by default, which is pretty okay. It provides you with some of the code that is needed to to actually check the username and password and grant access to some of the code. So, but the problem with the Play secure model by default is that it blacklists the code. Basically, Play is an MVC framework model view controller. Those of you who are developers, you know what that is. But basically, for any kind of form or any kind of URL in your application, you basically have a controller that will gather some data and display it to the user. So, and with Play Secure, you can actually tell in your code declarationally that this controller actually requires this kind of permission, and this one requires another permission. If you forget to put this declaration it's actually in Java, it's just the annotation. So if you forget to put that, and developers may forget that, then any user without logging in will be able to access, or actually at least try to access this controller. And then you can only pray that your code will not expose anything that is not allowed for the non-logged in user. So basically what we did with the Play Secure module is that we actually extended it to do whitelist checks instead. So it means that if we forget to put the access check, then by default is forbidden. And it actually protects us from many of the occasional mistakes that programmers can do. Because you will discover very easily that something is forbidden, but you probably, the problem that something is accessible, well, it shouldn't, it will be left undetected for a long period of time. So we changed it to whitelist and the two-factor, of course. When you log in our internet bank, you can use 3 types of authentication. It's SMS, as I mentioned before. It's the TOTP, it's time-based one-time password. It's basically, in our case, we use Google Authenticator implementation of that. It's almost as secure as SMS, because it's also the code for logging in is generated on a separate device on your mobile phone. But the good thing with this thing is that there is no traffic involved between the banking server and your mobile phone. Because currently, especially on Android devices, it's being shown that it's all too easy to have a malware on your phone that will intercept all the SMSs and actually will forward them to the attacker or something like that, and you will never know. So this one, maybe in some cases, is a little bit better, because you cannot intercept something. And with SMS attacking is also been shown, I think, by British Telecom. There was a case when the guys actually redirected the mobile phone number to another number by just using the social engineering. And in that case, they could log into the internet bank and confirm some transactions. So maybe it's good that in Estonia we don't use that method, but in Russia, the reality is one of the few methods that actually work and widely implemented. And CAP is similar to our Estonian PIN calculators, is the thing that actually is a reader where you can insert your bank card inside of it, and it will generate the one-time password based on your bank card. So it's almost like a PIN calculator, but the thing is that the reader is shareable, so I can use the same reader as my friend or my family, but the thing is that I need to insert my bank card in order to get access to the account. And for two-factor, of course, we use that for authentication, and we use that for confirming of all the operations. So that protects us from cross-site request forgery, and it protects us from many other types of attacks that we have a second device and second confirmation of things. So now the brute force attacks. Of course, if you have the username, password type of stuff, there will be somebody who will dare to actually brute force password of some user. So what you need to do at the minimum is actually to lock your users. What we do if the password is entered incorrectly, several times. So you can go very far with this locking, but at very least you need to lock it like at least temporarily for some time to make the brute forcing a lot slower. So most of the even Unix authentication tools, they do that. So if you enter your password incorrectly, the response is delayed to you, and if you enter it correctly, then you proceed right away. So what we do, we don't block users permanently, because in that case it would be easier to do the denial of service attack. So you just go through all the users and lock them out from your system. So what we do is that the locking is temporarily, so it's restored automatically and users can actually access the system, but it will prevent the brute forcing. So another important thing is that some Estonian banks, for example, and many Russian banks, they use usernames that are predictable. For example, Swedbank, they use the numerical login codes still, and it means that it's very easy to predict usernames and try to brute force usernames on a mass scale. So basically, you will not be brute forcing one single user, but you will be brute forcing all of the users at the same time. And in this case, locking doesn't help you. So what helps you is that probably blocking on the IP level. So it means that if there is an IP address that actually tries to log in with several different users, you need to lock this IP out. But the best way that you can do is actually make the usernames not predictable, so that it wouldn't be easy to, knowing some usernames, it wouldn't be easy to actually guess other usernames. So we let users choose their own usernames, and it means that there is a much bigger variation of what users actually use as their usernames. So another thing that developers often do, and in this report that I mentioned before actually also said that something like 30% of the banks are affected, is that you disclose extra information in your error messages. For example, when user tries to log in, you say that your username doesn't exist or user doesn't exist. It makes attacking so much easier. So you can just go through the random usernames to find, okay, this one has another error message, so it exists, then I need to try to brute force the password. So what we do is actually there can be like 10 or 15 different reasons why a user cannot log in, starting from incorrect password, inexisting user, user being logged in or something, whatever. It makes sense to give the error messages as general as you can, so that the attacker cannot guess from the error message about the state of your system or state of the user. So, another great thing that user, or actually the bad guys try to attack, is the password recovery forms. So we actually, okay, that's another thing. So password recovery forms are easily attacked, because from there you can also find out if user exists or not. You can use that to try to, hey, my username is like that, I forgot my password. So what we intentionally, we don't provide automated password recovery for the internet bank. Because it's so much, there are so many cases of abusing the systems. So basically, the security of the whole login scheme depends on your password recovery mechanism that you do. So we do password recovery only by phone, and then the operators, they have more possibilities of verifying the user. Of course, social engineering is still possible, but still it's a better way, in my opinion. So what goes about the trade-off of usability and security? Then often security professionals think that captchas are the answer. And if you think about captchas from the usability point of view, it's a complete nightmare. I'm not sure about you, but I hate captchas with a passion, because maybe I'm not such a good human, but for me it's sometimes very difficult to decrypt the stuff that we are showing to me on the screen. So we try to avoid CAPTCHAs as much as possible, and there are other ways of actually doing similar things, of preventing machine-based access to your system without CAPTCHA. So you can do all kind of tricky, like you generate random fields, inject them into forms and whatever, because most of the attackers, they don't use the real browser with all the JavaScript capabilities to attack your website. They actually use their own tools, and their tools, they are not implementing everything that the browser can do. So it's quite easy for you to write some code that will inject additional parameters into form or something like that, that will stop most of the attacks that usually CAPTCHAs are responsible of stopping, like the brute force attacks. So don't use CAPTCHAs, please. This is not from a security, but from the usability perspective. So next are the passwords. So passwords, of course, I'm not talking about forcing people to use the secure password and everything. It's, in general, it's better to avoid passwords at all. It's what we do in Estonia in case you use ID cards or a mobile ID, because passwords are always will be less secure than other things. But of course, what many people, it's the basics, but many people forget that you should not store passwords in plain text in your database. And because when somebody gets access to your machine, either with XXE or anything else, you will be doomed. And even Twitter, they had problem with actually their password database stolen. Of course, they had the passwords hashed, but they weren't hashed very securely. The funny thing about that, when we actually were implementing the first internet banking for Bank St. Petersburg, there was a previous internet bank that we wanted to offer a seamless migration from the old internet bank to the new system. And the thing is that we didn't want users to go and like request a new password from customer support or something like that. That would be a huge load. So what we did, we tried to migrate passwords from the old system. And it required a bit of reverse engineering. That was a pretty fun part, because in the end we found out that the old system actually stores passwords in base 64 encoded SHA-1 hashes and without any salt. And that was the first line, that was the first thing that we discovered, and we actually implemented that. And many or most of the previous users, they could log into our new system. We were pretty happy until we found that there are some users still who cannot log in. Though those were the guys with passwords longer than 10 characters. So the funny thing that these guys, I don't know what they were thinking about. They were hashing only the first 10 characters of the password, and the last characters were completely useless. So when people entered the password to our system, we hashed the whole password, and we did a different SHA-1 hash, and the authentication didn't work. So please don't impose any limits on the password length. So the longer it is, the better. There is absolutely no point of limiting that. And another group of users who couldn't log in, they were having Russian characters in their passwords. And in the end, we discovered that those guys were using this kind of encoding instead of the UTF-8, which is a good idea for all new systems which are written nowadays. So we actually migrated the whole database. The old users, they can log in, but we needed to improve on that, because this is an okay system for storing passwords, but it's not a really good one. So we actually introduced, it's quite easy to migrate users to new type of password storage, because when user logins successfully using this algorithm, you know the password at that point, the password that actually unlocked this SHA-1 hash. And at this point, you can actually generate a new hash with newer, better algorithm and store it in place of the old one. And then this user, after logging for the first time, they will have a more secure storage of their password. And like that, gradually, you can actually completely seamlessly migrate all the users to the newer password storing algorithm by updating their hashes when they're logging in. So we, of course, we added salting. And if you don't know what is a salt in the password hashing, then you should Google about that. So the mobile authentication. Maybe I don't have the time to show it to a live demo for you, but the thing is that using SMS authentication on mobile is insecure, because in that case, you use the same device for receiving the code and logging in. That's very insecure, because if your mobile phone is infected, the malicious software can get into control of everything if it's delivered on the same device. So the thing is that you need to have another authentication scheme on the mobile device, and also in mobile device you have the bigger probably usability issues, because on mobile device you need to access your data quickly. You don't care to do the whole multiple-step authentication process. So what we did, we actually authorized the device that the user first time uses that, and then we generate the authentication key that is encrypted by a relatively short PIN that the user enters. And the thing is that in order to log in next time, user needs to enter that PIN, and the PIN will decrypt the authentication key. Now, if the device is compromised again and user gets the encrypted authentication key, they can probably brute force all kind of pins and get the correct key. So to avoid that problem, we actually made sure that by only decrypting the key, you have no possibility to understand, is the decrypted key now correct or not? So basically, there is no way having the encrypted authentication key to decrypt that offline. So you need to check every decrypted key with the server, and only then you realize whether it's correct or not. So that prevents the brute force attacks on the PIN, but provides the usability and convenience for the user. So the user can actually, and for the security, of course, if there are more than 3 tries of sending us the decrypted key and it's wrong, basically it means that we need to invalidate the key and user needs to authorize the device from scratch. So now goes the sessions. So when the session is active in internet banking, Play has a very good thing of providing the stateless sessions. These are basically signed cookies. So all the data that you put in the session, it's digitally signed, and it's actually sent to the client, and then it returns back to the server. We check the signature and only then read the data contained in the cookie. That's a good thing from an operations point of view, because you can you scale absolutely horizontally. You put as many as servers, and you don't care if one server dies. You don't do any session replication. Any connection goes to any server, and any server can actually handle the request by the user. So the key here is the signature. So, and stateless sessions means that actually all the data in the session is stored only in cookie. It's very limited in its length, and it means that as a developer, we don't put any huge objects into the session. So the common problem with usual web applications in Java especially is that you put a lot of data in the session, and then you actually break the back button, or you introduce bugs which allow the bad guys to skip some steps in some flows. For example, if you have a flow of making a payment, you first fill the form, then you confirm it, and then when it's done. So if you store this payment, which is to be confirmed in the session, it's quite easy for you as a developer make a mistake and allow the malicious guy to bypass the confirmation step, go to the 3rd step right away, and you get this payment for a session. You think that it's already confirmed, and you execute that. So with stateless sessions, it's better because you need to pass all the parameters with all the requests all the time. You don't store many things in a session, and it makes it a lot harder to make the mistake of bypassing of some steps in some flows in the UI. So that's a good thing for the developer. So cookies are convenient, but by default, Play doesn't do that. You need to set secure and HTTP-only attributes on your session cookies at least. So secure means that the browser will pass this cookie only over the HTTPS connection, and HTTP only means that the cookies are not accessible to JavaScript. And it means that it's much harder to exploit a cookie even if you have cross-site scripting vulnerability somewhere, it's much harder to exploit the cookie stuff using this option. So we had very funny time zone problems with the default cookies as well that play sense, because it turned out that in Russia many people use pirated Windows and some old Android devices, and the default cookie expiration mechanism actually checks for the expiration date on the client side. And the problem was that many of the older Windows machines and older Android devices, they didn't know that Russia now uses another time zone. It's now GMT +4 year-round, and many of them thought that it was GMT +3, and the cookies were expired instantly. So basically, many users with pirated Windows who don't update their Windows, they couldn't log in. So we needed to invent our own system of expiration. So we done expiration on the session side, or on the server side. So basically, we use session cookies. Session cookie means that it's a cookie that is not, it doesn't contain the expiration attribute. So the browser sends it back only until the browser window is open. So another problem is that some users are not logging out, they're lazy. So what we need to do is that if they close the browser, that the browser will forget this session, and this is the session cookie that provides this functionality. So, and what we do, we include our own server-side expiration time to this cookie and check it on the server side. So we don't accept the cookie if this time that we inserted there it has passed. So also the cookies, of course, are tied to the IP. So even if you intercept the cookie and try to access it from another machine, you will be instantly logged out. So it's also to prevent vulnerabilities that may happen. So of course we use also the last login time, CT, avatar, and the user can see the full login history in the internet bank. So to prevent users from having the unauthorized access. Now I'm almost out of time, so I'll show this as a last slide. Is basically what usually in a web framework, for convenience, they introduce, or they have a notion of binding. It means that they automatically bind request data that you send from a user. They bind it to your objects that you actually have in your code. That's very convenient for developers, but it's sometimes very insecure. For example, what Play Framework does by default is that if the user sends some kind of ID with the request, it will try to automatically load this object with this ID from a database and bind it automatically for your code. And it can lead to problems if you don't check that this object or this ID really belongs to the correct user and can be accessed by this user, all kind of stuff. So it was much easier and actually much more secure to disable this functionality in Play Framework so that our IDs are not bound automatically and the data is not loaded automatically from the database by the framework. What you also need to do is actually, and it's a common vector for attacks, is all incoming IDs must always be checked. So if you receive any ID from the user, you always need to check whether this user has the access to this ID in your code. So how we handle that is that we actually, all of our, we deal with that on the API level. So inside of our system, when we actually do requests to subsystems, we always include the current user in all API calls together with the IDs that need to be loaded, and we always check when loading that they actually match. So that prevents us also from forgetting of checking of these IDs that are coming from a system. So that's basically most of the important things that I wanted to tell you. And if you're a developer, then please follow these things. But nothing can replace the penetration testing And just be smart, know about vulnerabilities, and do test your applications. Thank you for listening.